come from such a long way away. How many of you walked here? How many of you walked here? How many of you took a plane? How many were on a plane? Oh my gosh. I want to say from the bottom of our heart here at CS50, we are so thankful for you. And please tonight, we want you to contact your family. And we want you, I'm serious, I want you to contact your family.
Right now?
Please extend our thanks to them for allowing you to come here this distance, to be away from your family and to work so hard. It takes such a commitment to have done what you have done. But today is not the end of your journey. This weekend is not the end of your journey. This weekend is just the start of something.
Horrible days.
So I want to see who has traveled the longest way. So not only is your family proud of you, but your city, your province is proud of you. Last night the minister visited you and the school. You're part of the reason. You are the reason this is all happening. We are so happy to be here with you today. So what we're going to play is we're going to play a game really quick to get us started called Count to 23. But we can do it in Bahasa. So, how do you say the number 1 in Bahasa? Okay, so we're going to count. So we're going to hand off the mic. We're going to go 1, 2, 3 in Bahasa. Okay, here we go. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And what number is 23?
18.
And here?
20.
Someone 20.
20.
21. 23. And then you go 1 again. And now we will spend the entire weekend making a better algorithm for that.
No.
It's so to be with you here today. I'm so honored, and we're so happy to be joined by the Harvard team today, to be here at GIS and to be here with you. So please do send our thanks to your family. To get us started, we need to make some noise to bring on Dr. David Malan.
Thank you so much to CS50's own Guy White. This is a very hard act to follow. In fact, he was kind enough to pass the applause off to me, but I think we should give it back to him. And allow me to begin this way, if we may. This is
CS50!
So nice to have all of you here with us this weekend, and welcome to CS50's whole community. We thought before we dive into the behind the scenes of CS50's pedagogy, do a bit of a pop quiz of sorts. Well, the next 2 days are meant to be about CS50. It's meant to be not what is CS50 and what is computer science, but really why is CS50. And among our goals for today and tomorrow are to look initially at the pedagogy behind CS50 itself, looking at why we teach things the way we do, so that you can decide for yourselves as a teacher, do you agree, do you disagree, do you want to adopt the class for your own students, do you want to adapt the class for your own students? So there is no one way to teach certainly computer science and even CS50, both back home and around the world, the teachers like you really modified it as they see fit for their students. And what you'll find typically is that when you're teaching computer science or CS50 for the first time, you might indeed want to adopt the class. Lean on us. So have your students watch, for instance, my videos or some of our shorts online until you get comfortable yourselves with the material. And then maybe later in the year, or maybe a year or two later, you can adapt the class and make it your own, doing what you agree with, not doing what you don't disagree with, and instead of having your students watch the videos, maybe just you watch the videos and then bring the same material to life yourself in the classroom. But before we dive into the why, allow me to thank all of our amazing hosts here at GIST. You met some of the ministry last night. I mean, a round of applause if we could for everyone who's made this. Allow me to take a moment too with that same microphone to introduce not just Guy and myself, but more of CS50's team, including CS50's own, formerly GIST's own, Bernie Longboy.
Siam. But is it Siam or I could never get that one right. Siam Sore Malam. Anyway, welcome. So happy to have you all here. We waited for, 6 months and super excited to have you all here today. So I'm Bernie and I'm in charge of outreach and partnerships. So really this big event is something that we all worked on and we're really excited to kick off today. So again, welcome. And if you have any questions or anything, just look out for any of us and we're happy to answer them.
Allow me next to introduce CS50's own Carter Zenke, who has the distinction of running CS50 itself back home at Harvard with our 600, 700 students over the course of the year. Carter.
It's so good to see you again. My name is Carter, and we're going to lead the course's lectures. I lead our sections, our stations, our labs, these hands-on programming classes. I also get to work with our 80 teachers that we have at Harvard College called Teach the Class. It's a big group, we are a big group here, and I love being part of that community. So it's like to be part of the community with you all as teachers and grow in that way. So thank you for having me here in Indonesia.
Next, introduce all the way from New York City, Margaret Tanzosh, who teaches her own classes of computer science for high schools and has been wonderfully working with CS50 for years, adopting and adapting the class as she sees fit too.
Hi, so nice to meet all of you. I'm so excited to share what I've been doing in my classroom at CS50 for the past 8 years. I was actually one of the first high school teachers to take on the course and do a combination of adopting and adapting and everything in between. So I'll be talking to you tomorrow a little bit about what I do in my class, and I'm going to ask you to think about and visualize how you're going to run your class as well.
And I dare say he needs no reintroduction, but for those of you allow us to ask Guy to introduce himself.
So I'm Guy White from Portland, Oregon, where the weather is a lot like this today. It's raining there right now. I just want to say again that it is my pleasure to have worked with you. Truly, please thank your family. You just filled my heart. Thank you so much, everyone. And I look forward to working with you over the next 2 days.
The mic, because otherwise we'll stop recording everything. But not only are we joined by GIST's video team here, we also have Max and Sochi and Rongshin. So indeed, the videos that we filmed this weekend will make available ultimately online. All of the photos that we've been taking out in the photo booth will follow up with a URL so you can get our versions thereof. And all of the materials today and onward will be available on this website here, cs50.ly/Indonesia, which will give you links to the slides, any code that we distribute, the agenda itself. So this is a URL that you should keep in your phone today and tomorrow, but perhaps after the workshop as well. As we forge ahead today, please do interject at any point if you have questions, and also during the breaks or lunchtime tomorrow, please feel free to ask any of us questions that you might have. But thought I'd give you an overview of what we hope to do over the next couple of days as follows. So today we are at that first white bullet CS50 explained behind the pedagogy. Between now and 4 p.m. what we'll do is focus on that why of teaching CS50 the way that we do. We'll then take a 30-minute break, and at 4:30 p.m. we'll resume focusing on what we call back in Cambridge micro-teaching, giving everyone an opportunity to very comfortably, very safely, very experimentally teach something to some of your fellow teachers. And we'll explain after the break what that will involve. No prior preparation is expected. Maybe we should teach bubble sort in all of the individual rooms. We can do that, but we'll explain what that's all about. And it's meant to really help you get any of the nerves you have out now, because especially if you're teaching CS for the first time, or it will have been a few months since you've seen your own students, it'll be a much safer space, much more comfortable space to be nervous among your colleagues than necessarily feeling that way in a few weeks or months' time in your classes. Tomorrow, meanwhile, we'll get started early, and over breakfast, we'll distribute a packet of puzzles. Some of you might know online that we have a tradition of CS50 Puzzle Day. More on that in a bit. So upon arrival tomorrow, you'll be provided with some food as well as some puzzles. Now, you don't have to solve all of the puzzles. Somewhat easier, medium, or hard, but the goal is just to enable you to chat with more teachers than you came into this workshop knowing, so you hopefully make a few new connections and friends and colleagues while having some fun solving the very types of problems that we'll make available to you in the coming year if you want to run a similar event for your students. We'll then focus on teaching CS50 itself and actually experimenting with it, talking about methodologies thereof, managing a CS50 classroom, or really a computer science classroom more generally. Focusing thereafter on comfort levels. As you might know within CS50, certainly back home where we have a lot of undergraduate students, we have problems for those less comfortable and more comfortable and somewhere in between too. And so what we'll discuss is exactly how you too, having students who might have been programming since they were 6 years old, and some students who don't even have access to computers outside of school, that you can balance those two different types of demographics. We'll take a break and do a lurking lunch with some Q&A, followed by a hands-on opportunity to actually, and this will be much more fun than being graded by the teaching fellows, actually grading some sample work so that you'll get a sense of what is a 5 out of 5 for correctness, at least as we view it, or design, or style, and getting you to think about the teacher perspective of what you've just experienced for months as the student as well. We'll then have a round 2 of micro-teaching, an opportunity to improve on, however later today goes, and ultimately we'll give you an overview at the end of tomorrow of all of the resources that will be available to you from CS50's team, both now and in the coming months and years, and then we'll conclude with a presentation of your very own CS50 certificates, and congratulate you and acknowledge you. I do think the right way to think about CS50 as being open courseware, freely available open content, is that you can indeed adopt it or adapt it. And to reiterate, adopt in our mind means let's lean on us heavily. Have your students watch me, watch Doug in the shorts, use our problem sets as is, use our grading as is, until such time as you just feel more comfortable maybe making some changes or creating your own problems or presenting the material your own way. Now you can certainly do that from day one if you're already comfortable, but in general adapting the course would be just that. Like any good teacher, using what you like or what you don't like and changing what you don't like in order to really make the class and your students' experience your own. And so that's generally how we frame the course. It's not some curriculum, it's not some textbook that you have to either use or not use. So do know that first and foremost. And those of you who have never taught CS before, or maybe coming from another field, maybe it's math, maybe it's something completely unrelated, realize and know that it's perfectly okay, and I would encourage you to just learn along with your students, especially those kids who are already a little more comfortable, maybe have been programming even longer than you. They're going to catch on if you're just pretending to know what you're talking about, and so no good will come from that. So I would encourage you to be comfortable feeling uncomfortable at times, and if you don't know some topic or some answer, just offer, we'll figure it out together. And indeed that plays into really something that's a little unusual within CS50, or at least certain courses back at Harvard, is consider, if you so can, with your schools, using students as your own teaching assistants, or teaching fellows as we call them, or TAs. And by this I mean, if you already have that one or few students who probably don't really need to be taking the class, but maybe it still fills in gaps in their knowledge, so it's not pointless for them to be taking the class formally, but if you already know that they're going to be the kid with their hands up, or they're going to be the one getting 100% on the assignments already, consider, if you can, deputizing them, so to speak, so as to be, in addition to you, one of the humans walking around helping their classmates. For instance, we give some of our staff little lanyards that say CS50 that sort of make clear that they are part of the team. So little touches like that, or name tags, or just knowing that this this person or that is the teaching assistant for the class. That's an invaluable resource, truly, especially if your class is somewhat larger. You now have 2 humans, or 3 instead of just 1. So here we go, CS50 explained, behind the pedagogy. This is the why, and please interject at any point, and of course we'll make these slides available for reference thereafter. Thought we would present to you a few types of answers to why, namely on the course's languages, on the course's lectures, or really classroom curriculum, and finally focusing too on some of the course's problem sets. So this is an image you might recall, and it might still feel this way. This is a photograph of a hack down the road from Harvard and MIT, where some industrious students connected a fire hose and fire hydrant to a water fountain. And pictured on that sign there, even though it's very pixelated, is a statement along the lines of getting an education from MIT is like drinking from a fire hose. Which is to say, there's no way you're going to absorb or swallow all of the information at once, and it is a little bit forceful. But the point, though, is that to expect this from the get-go means that you can be comfortable, feeling uncomfortable from throughout the course. It is not the expectation, even of our own students back home, that they'll master each and every topic, but that they'll have that exposure. CS50 is indeed meant to be this foundation for, this introduction to computer science, not necessarily something that's going to come naturally to all students the very first time they dive into it. So with that said, why do we use the languages that we do? Because CS50, as you might have gleaned, is already a little different from many introductory courses, most introductory courses, which are typically a Java class, or a Python class, or a C++ class. They're very language-centric, and they're not. Because over the course of 12 or so weeks, we of course go from scratch to C, to Python, to SQL, to HTML, CSS, Java. I mean, there's the fire hose right on my fingers. It's a lot. But what's the point? Well, very early on when I actually started teaching CS50, the course was pretty much only taught in C. Though there's a little bit of a language called Ruby at the end. But students would exit the class, even when I took it 20 years ago, with the mindset that they learned how to program in C. And so it was rather exclusionary to them understanding or diving into other courses or other languages because they had learned C. They hadn't learned computer science, and they hadn't learned how to program, period. And so among our goals with this suite of languages is twofold. One, to make sure that students do feel that they learned how to program, period. Or if we want to qualify it, they learned how to program procedurally. So not so much object-oriented stuff, not so much functional stuff, if you're familiar with these terms, procedurally programming. And this is the type of languages we generally introduce. But beyond that, among our goals in CS50 is to ensure that it's a foundation for students taking computer science for the very first time before they go on to higher level classes and more computer science and programming so that they're prepared for it. But at least back home at Harvard, half of our students never take another CS course before, and we know that going into it. And for those students, we felt that it's very important that they not only have the conceptual mindset of a computer scientist, they know how to process information and think about problem solving more effectively, but they also have some practical skills that they can bring back to the arts, humanities, social sciences, physical sciences, medical sciences, and the like. They just have some practical programming techniques. And so while we start with this terminal window using C, and we end with more of a familiar paradigm, namely, of course, web programming, that's also increasingly used, thanks to HTML, CSS, and JavaScript in the mobile world as well. So the students are prepared to never again take a CS class, but at least to continue to teach themselves new languages. So why Scratch? So back in 2007, one of the first changes we made when I took over the class was change the class from introducing, no joke, assembly language in the first week of the class to Scratch, which is, dare say, like the complete opposite. And even though you might not know much assembly yourself, if you think back to week 2, we talked about this and we showed the very scary looking code that wasn't even zeros and ones. It was a little scarier and more cryptic, but that's still with us today, and that's a worthy topic for a computer science or engineering student to learn, but maybe not on the first day of class. So Scratch for us is really meant to introduce these ideas, these building blocks to students, but in a way that's just fun, and better yet, in a way that they can share with their roommates, or send a link back to their parents back home, and sort of delight in what they've created, very visually, very graphically, without the stupidity of semicolons and parentheses and curly braces and stuff that is just not intellectually interesting. Certainly something you have to get over eventually, but again, not on the first day of the class. And so it's very deliberate, as you might recall from our own week 0 and week 1, that when we introduced this as the first program that someone could write in Scratch, We then tease students with this code, which, my God, that escalated quickly. But then if you think about what you can do with these visuals, we briefly color coded. So now everything that's orange has to do with the green flag being clicked. Everything that's purple has to do with the say block. And yes, it looks ridiculous. It's not going to be obvious what most of those symbols do, but that's not the point, certainly on the first day. This program, of course, still just prints out hello world. And then, of course, we translate it to the actual scratch blocks so that in the subsequent week one, as we call it, now students hopefully have a mental model where they're comfy with the idea of functions and conditionals and loops and maybe a few other ideas like variables and more. But now we can literally side by side compare the two so that if you're comfy with the program you wrote, just having the cat say hello world, okay, it looks a little harder to master now on the right, but it's just the same idea. So the syntax will come, but the ideas are the same. Same thing here. On the left here, we have an if, else statement in Scratch, and of course it looks much scarier to a student unfamiliar with textual code, but it's the same idea. And so pedagogically, the motivation is to really assure students that it's fine if you don't quite get all the syntax or you make stupid typographical errors. What's important is that you understand this, and you'll get, with practice, more comfort with this. And of course, we can do this with loops, and we can do this with so many other different features, including transitioning, and this too is deliberate, mid-semester in week 6, from C to Python. You might recall that we used the same kinds of slides where I pulled out the exact same pictures of Scratch blocks, but then showed students how we would translate it to Python as well. And this is very intentional. Among our goals with CS52 and teaching these different languages is to show students that you don't need to take a whole course on Python to learn Python. Now, that might accelerate your learning, and there is something to be said for learning from an expert in the field who might be able to structure your lessons, but in reality, they're probably not going to take courses endlessly in the future. And so all the better if we can give them some discomfort now, looking some things up online, looking at some slides, Googling for some answer as to how to do the syntax, but making clear to them that, even after 6 months of CS50, you've seen most of the ideas out there. And you just now need to translate them to some different syntax as well. We introduced, beyond those languages, of course, SQL for databases. And here is where I think teachers, among them Margaret and others, have made different decisions as to how to structure their classes. So SQL we introduced so that students have a real-world database that they can rely on. And nowadays, data science and statistics are increasingly popular, so it's just a really useful tool, especially for those students who never take CS again. And we use it so that at the end of the term, especially when we introduce web programming, students just don't have to use like a CSV file, which would work for small websites. You could read and write data, but it's not the right way to do things for any decent number of users. So we introduce students to at least the simplest flavor of SQL, so not MySQL anymore, or Postgres, or God forbid, Oracle, or the like, but rather just SQLite, which shows all of the ideas of the language, but also helps us get the job done on the web or in mobile environments too. We introduce HTML, right? This isn't going anywhere, like it or hate it. It's being used now for the web, of course, but also for mobile applications increasingly, especially since in this room, some of you might have iPhones, some of you might have Android devices. That means twice as much labor for a company or an individual developer to make if they want to have an app that is cross-platform. So increasingly you're seeing, even though we don't talk about this in CS50 much, you're seeing HTML, CSS, and JavaScript being used, so you write the code once, and then you just put it in a different type of rectangular window, if you will, so that it works on both Android and iOS as well. So we introduced this, though, again, so that we can offboard students at the end of the semester to an environment that they can actually build real-world tools with. Of course, we introduced Flask, which I think is probably the simplest of the Python frameworks that doesn't abstract too much, doesn't get especially bloated like I think Django gets, especially if we just have a week or two to introduce it. And this, of course, is how we introduce students then to writing code, but now interacting with users via HTTP and the like. And as for tools, of course, we've introduced, over the past 2 years now, Visual Studio Code, implemented by way of GitHub Codespaces in the cloud. For us, this too is very deliberate. Code.org has their own platform. Many of you might have used Replit or certain other platforms out there, or even client-side IDEs like Eclipse or NetBeans or the like. It's deliberate that we use VS Code insofar as it's a very general purpose solution. It's not one language specific. It's also free, which is great. It's also very popular nowadays. It's certainly among US tech companies and increasingly internationally, it's just VS Code the development environment of choice because it's so extensible by adding extensions and plugins and the like. And so this is deliberate too, that we want students not using a toy CS50 specific environment such that when they finish the class they have no idea how to write code, but rather they use this in the cloud, and then at the end of our term we try to offboard as many of our students as we can by giving them instructions and videos for learning how to install Python and VS Code and anything else they want on their own Mac or PC. It's still a headache even a few months into the class, but it's not like a barrier on day one when they just want to write hello world, but they can't get like Python working in their Windows path or something like that. So it's deliberate. We start in the cloud but try to end in the local Macs and PCs. Any questions now on this whirlwind tour of our use of languages, tools, and why? Questions at all? Yeah.
Okay, probably this is about SQLite. Is it okay to ask specific about SQLite?
Sure, try me and I'll defer if it's too specific.
Actually, I was thinking about SQLite is it like Google Drive? Because in Google Drive there is capacity, right? For example, 100 gigabytes, 17 gigabytes. But in SQLite, is it any capacity? For example, if we make a database and then I want to upload some pictures, and then is there any capacity? How much and how big is the data?
Sure.
Yeah.
A really good question about the capacity of a SQLite database as it relates to something like Google Drive. The capacity of a SQLite database completely depends on the device that you're storing the database on. As you might recall from the end of the class, a SQLite file is usually named in something like .db or even .SQLite, and that's literally just a file, a binary file made with zeros and ones that might be 0 bytes if there's nothing in it yet. That could be a megabyte if you've got a few tables and rows. Could be 100 megabytes if you've got a lot of data. So the only limiting factor is what's available on your own Mac or PC or Android or iOS device. Good question. Other questions on languages?
CS50 already make a development for us to make simple by setting some requirement for code that make us easy to write the code, just like using Visual Studio for online. And can we use later as a teacher for our students that the environment that already provided by the CS50 teams?
Yes, absolutely. So you can in fact use code.cs50.io, which will lead you to the same environment that you've all been using as students the past several months. Your own students can use the same. There are also other ways you can use code spaces even independent of CS50, and what we'll do in the coming weeks is likely hold a Zoom-based tutorial for those who want to see other ways of using these same tools. You can actually use code spaces itself as a feature for free because of grants that Microsoft and GitHub provide that essentially gives you more control over the student's experience, whereas code.cs50.io automates a lot of things right now. So both options.
Including all the library that CS50 gives to us?
Yes.
In C or Python?
There is nothing you have just experienced in the past 6 months that you will not continue to have access to. So allow me to transition now to the more curricular side of things. And as you might know from even the videos, we tried within CS50 on that beautiful stage that is Sanders to create as many memorable moments for students as possible. And what this means is just trying to bring the material to life in ways that like PowerPoint slides do not belong, or just talking about the material, or having students read a textbook. It doesn't necessarily mean that these memorable moments and these physical demonstrations are showing or introducing any more material that you couldn't introduce via those other technologies and techniques, but that you're creating hopefully this visual, like the 8 or 9 of you who came up, like you will never again forget like how not to do bubble sort perhaps by way of that demonstration. Until then we actually did it in the one final way. And so the goal is just to give that visual that persists long after term's end for many more months, maybe even years. And we don't do that for every topic, of course, otherwise we could be here forever, but we try to do it for some of the most difficult topics, or at least those topics that lend themselves to theatricality, so to speak. And so I thought I'd share with you a few screenshots and a few slides that explain why we did things this past year the way we did. So with that said, the first and foremost, maybe most memorable for students, tends to be our implementation of binary search at the very beginning of the class. So here is me in a very awkward screenshot, like tearing that phone book, which admittedly are getting very hard to find, so much so we tried to find one here in Indonesia and we could not. They're even hard to find back home too. But this is an example that honestly, after 16 years of teaching CS50, some students, alumni, still come up to me and mention, oh, I still remember when you tore that phone book. And there's something to be said for certainly the memories that instills, but also just the idea. Like those students hopefully will never forget the essence of binary search, or even if they forget the term, the essence of dividing and conquering a problem, like dividing and dividing and dividing again. And so when you have access to props like this, or anything, any collection of paper that you could tear in this way, consider doing it to bring that material to life. Vary it up. Sometimes I have students come up onto the stage and I have to whisper into their ear that yes, I want them to tear the phone book, but that just allows you to create all the more visuals for your students to latch onto, even as they might struggle with those same topics. Something like Scratch, meanwhile. So Scratch is meant again to be this graphical, fun, accessible opportunity to bring material to life. And even though some of your students might have already used Scratch or Scratch Junior as kids in school or at home, it's still an opportunity to sort of elevate it intellectually to make clear that it's not just a game or something to poke around with. It is computer science. It is an example of programming, certainly, that's much more accessible than what they're about to see weeks later. And here, too, we have fun, especially in that first class, where if you're trying to convince students who might not necessarily even consider computer science for them, demographically, academically, or otherwise, Scratch is just a nice way to sort of put everyone on the same playing field. And you might remember from week 0, it's great when you can get students literally jumping on stage and implementing this. Recall that I think he was trying to hit the whack-a-mole, so to speak, as we say in English, where the thing was moving up, down, left, and right. So just this idea too. It's not maybe as high information content as something like tearing the phone book for binary search, but it's just fun. It makes students want to be there, basically want to come back the next day, and we particularly do these kinds of things at the beginning of the class as students are trying to figure out if this is indeed a world for them. With that said, binary itself, of course, is something we talk about early on, and this too is an opportunity to bring students up on stage. So here, for instance, didn't have paper, we actually had found plastic numbers that with light bulbs that lighted up, and we had our students represent the 1's place, 2's place, 4's place, and 8's place in a way that just allows us to get some audience participation. And really, pedagogically, for the students in the audience, or the puppets in the audience, to see the students on stage as themselves, sort of imagining like, what would I do in that student's position? So they're engaging a little more actively with it than in just listening to someone like me talk about these kinds of ideas. So debugging, we quickly transition to in our week 2, and we tell students about printf and print later in Python. We introduce them to debug 50, which is CS50 specific, but all it does is automatically open the built-in Visual Studio Code debugger. So that too is not CS50 specific, but we make it a little easier to use. And then of course we introduce them to, in our case, a 7-foot rubber duck standing on stage, or inflatable duck in this case. These are sometimes, well actually they've gotten very hard to find at that scale, but we also have, of course, these tinier little ducks that we actually give out to students. And they don't even have to be that big. You can find online, or you can make one's own out of paper, or the like tiny little ducks. The goal is to give students, recall, some inanimate object, something cute, something memorable, just to put on their shelf, so when they don't have a friend or roommate or teacher available to answer questions, they can just start talking through their ideas. And there's a reason that we do this, we sort of steer into this. And this is kind of ridiculous that we have this 7-foot duck among our teaching supplies, but the goal is to just normalize this. Not just to tell students, hey, go find something inanimate to talk to, but to say that, hey, if I can stand there for 3 hours in front of this goofy duck, you can certainly try it as a debugging technique, and some students do take that to heart. And indeed attest that this little guy proves helpful for them sometimes because they just hear the illogic in something they're saying and the proverbial light bulb goes off. How about now arrays? So arrays are one of the first data structures that we introduce students to, specifically in C in our case, and we introduce them initially in the abstract like this. And you might recall too that we show students even more of the computer's memory, but we try to focus on just a few bytes at a time, left to right. And from this though, we try to connect it to something metaphorical like closed doors. Like in the US, it's very common to have hallways filled with lockers where the kids can put their books and their backpacks and the like. And so we try to give them that mental model to latch onto like they used to have maybe in middle school or high school. And now some years, most recently this year, we were fortunate to find, 7 actual lockers. And these aren't even the big ones, though they're not fun to move across campus. 7 big lockers. But the point is that the door is closed. Like you can't see all of the numbers at once with this bird's eye view. You have to deliberately index into it one at a time. And this too, of course, involves not just me, but a student potentially coming on up to act this out, lending itself to that memorable moment. But this is the perfect example, too, of things where it doesn't need to be as high budget as this, right? The fact that I brought paper today with those numbers is exactly what we used to do back in the day. We might just have the students like turn it around when it's closed and turn it this way. So even though we're fortunate in Cambridge sometimes to have 7 feet ducks and like 7 of these red lockers, like paper and pencil and tape is all we used in my first several years of teaching CS50 because that's what I had at home or we had there on campus. So all of these examples are meant to be quite accessible. Didn't know we were going to do that demo at first, so here's a discussion of bubble sort and selection sort. Here, of course, we have those same plastic numbers that we use back home, but paper certainly suffices for this too. But this is an opportunity, again, to get the audience viewing themselves as, well, maybe thinking, my God, thank God I'm not up there on stage doing it. But they think to themselves, how would they do that? Or just like you all were wonderfully yelling, it felt like a game show up here, just rooting for the participants to actually sort themselves properly. That is probably a memory that will not leave you, will not leave them for some time. And I dare say it's a lot more fun to have that memory about something as arcane as bubble sort or selection sort. These are not topics that you go home and tell like mom and dad about all that commonly, but you might tell mom and dad and your friends about what you did in your CS class today when this sort of hilarity but educational presentation came to life in this way. Now, merge sort, recall, was harder than those two algorithms too, and it's especially harder for students to wrap their mind around what's going on, and we often try different techniques. So I talk about it, for instance, and I might show the pseudocode. I might then pull up one of those web-based animations with the graphics or the YouTube video that's showing it. That's deliberate too, because some students are very visual learners, some are very audible, some are very intellectual about it, and so by just trying 1, 2, 3 different approaches, hopefully we're getting most of the students on board. With this example here, this is just like a metal shelf we put together. This allows us to convey very visually with merge sort that the key to its speed is you have more space. Like bubble sort and selection sort just use in-place swapping here. You only need as many bytes as we had people, but merge sort you need at least twice as much space. Now, just for convenience, I actually use 4 times as much space in this demo, but I could go down, up as I do those merging. So this too, having a couple of shelves is certainly something that should be discoverable most anywhere. We talk about issues of scope, for instance. Recall that the issue of scope means like, where can you use a variable? And the short answer, at least in C, is if you declare a variable inside of curly braces, you can only use it inside of those curly braces. You can't use it in some other function or file. So we talk about scope in week 4 a lot with students because of our discussion of memory. But at that point, as well as for our swapping algorithms, we need to be able to, for our sorting algorithms, we need to be able to swap values. So you might recall that we really focus on swapping things, and this is a demo I've always liked where we actually use glasses of water. We get some food coloring, just to choose 2 different colors that are ideally visible by students, especially with color blindness, so you want to choose those carefully. And then you can have fun with this, as you might recall, like don't give the student 3 glasses at first, give them 2, see what happens. One year it was funny when I did this, the student just got a little creative and she just went like this and moved them, swapping them. It's not really what I meant. I wanted them to, of course, pour it left and right. But this is a fun example too. In case your mind is racing, I also thought I'd be really clever one year because it turns out, we don't teach this now in CS50, using bitwise operators. If some of you are familiar, there's an operation called XOR, or exclusive OR, which allows you to operate in C on individual bits, not just integers or chars or the like. You can actually swap two values in C, if you're clever, without needing a temporary variable. You can use this other operator that we don't use currently in CS50, but it's a pretty cool trick. And so I thought years ago that I'd try to simulate this by being very scientifically clever, and so I used 1 glass of oil and 1 glass of water, because I vaguely remembered from chemistry class that these two things shouldn't mix. Of course, it mixes, but messily with lots of bubbles, as I recall, so I was trying to be very clever, pour one into the other, then dump the other out here. Did work, so sometimes these demonstrations backfire. So another moment I would encourage you to do is to test things in advance, not in front of your students, but again, to just lend itself all the more to a memorable moment. Well, what about memory itself? Like in the US, we very commonly have along roads like these kinds of mailboxes, so they all follow a similar shape, and so it's very familiar to students. And we use these as representative of how we might store values. Now, these I did happen to go to the local hardware store, but you could mimic this with like a picture thereof or just a cardboard box or the like. And so we use this to give students just a more concrete visual of like what we mean when we say an address. Like we can tell them it's like a mailbox address, but there's a little something special or more memorable about showing that actual thing. And what I do too is you might have, at least in American football games back home, as we discuss pointers, these foam fingers tend to come out, maybe in soccer games as well around the world. You're like, you're number one. We just use it as a big pointer, like not to say we're number one, but rather the value is over there. So this is just, again, sort of a silly visual, though we're very careful to choose our school colors and the like, whereby this pointer, P, might be pointing at some other value, some number like N over there. So just kind of acting things out, taking a few moments to do exactly that same thing. But at the same time, and this might have been a discomfort for some of you, like we do get very low levels sometimes in CS50, and this is deliberate. In fact, one of the reasons why we don't use just Python in the class is because I think it's a really missed opportunity for students to like understand at a lower level what's going on inside of a computer. And if you only learn Python, and that's the only language you ever learn and then use, you can use a list, you can use a dictionary. Do you ever really understand what it is? Maybe conceptually at a high level, but there's something about, I think, pedagogically, just showing students what's going on underneath the hood. And don't abstract everything away, that they'll get it. Even though it might be very technical and pointers are a hard topic, the result is like, wow, like that light bulb does go off when in one line of code in Python, you can re-implement the entirety of your speller problem set code in C. And so that too is very deliberate to not be fearful of just getting into the weeds sometimes with students. So for instance, here is the very technical, pictorial way of describing a pointer P, storing the address of some value N, storing this specific number 50. But again, we can abstract that away with a number, and then at that point is when the foam finger comes out in class and I start pointing at it between those two mailboxes. Later on in the class too, you might recall this demonstration, and there's so many good little videos like this on YouTube and other universities' websites. Like, look for these things and hang on to these things, share these kinds of things with each other. This, of course, was Binky, as you might recall, made by a friend of ours at Stanford University, like in his basement with a little cardboard box and some clay that acts out, of course, what can go wrong when you actually use pointers incorrectly. And then toward the end of CS50, we introduce more sophisticated topics, data structures like hashing. So recall that hashing means you take as input some value, maybe a name, person's name, and you decide what bucket it goes into. Like this is the A bucket, the B bucket, the Z bucket. Or what we choose is I went online and I looked for playing cards, like that you might gamble with. But I thought it would be more fun and more visual to search for jumbo playing cards. And so we indeed have these like 18-inch cards that I can use very visibly in the class. We literally went to the hardware store, got some buckets that look like this, and we introduced students to hashing by literally bucketizing the values. And that's a technical term a lot of engineers would use, even though it's a little abstract for students, but if you use actual buckets, you sort of decrease that gap between the idea and the actual incarnation thereof. Lastly, among topics, maybe race conditions. Now, this is where things really get sophisticated in an introductory course. And as we tell students, CS50 is really a combination of what in the US and in many countries is called CS1 and CS2 combined. because we introduce students to software-based programming, but we also touch on data structures and algorithms quite a bit that many schools separate into two separate courses. So by the end of the class, we're nonetheless talking about very sophisticated topics like this that often come up in databases, be it SQLite or otherwise. So here is the tiniest refrigerator we've yet found. We were fortunate a couple of years ago during COVID, we were collaborating with some friends at the theater on campus where they had a whole warehouse of actual props that were used in plays and musicals that had been used on campus. So in some years we've used an actual refrigerator that was as tall as me. Turns out it's a lot easier to carry around a foot-tall plastic refrigerator here, so as to paint the same picture for students. This, recall, was the scenario in which, what had I run out of? If you recall. Oh, database, yes, but what was I pretending to run out of? And I needed to go to the store to get more of it. Milk, yeah. So I picked a beverage and said I was out of it. I had to go to the store to get it, but if I don't leave a note, or if I don't lock the database, my roommate, for instance, could come home, open the variable, if you will, and inspect its value, make a decision based on the exact same value as I did, and that's when a race condition arises, because one of us is going to come back first, the other is going to then arrive, and then we have too much milk. This is exactly what happens in the world of databases, and in fact, I actually learned this topic myself, and a former professor of mine gave us this example of a refrigerator in an operating systems class that I took 20 some odd years ago. And so here's an opportunity too, I think, to not be scared of or disinclined to even introduce students to more advanced topics. I think especially if you can base it in something metaphorical, something physical, something theatrical, if you will. So that's a whirlwind tour of just some select topics as to the why.
Horrible.
What?
No way.
It is so much better being a teacher than a student.
Not again.
First, any questions on those memorable moments or the why by presenting topics like those? These are meant to just be examples to get you thinking. Certainly, you've spent the past 6 months on all of the topics. Yeah.
So last year in my class, we have left C and we move on to Kotlin because we thought that it would be easier for students to get into object-oriented programming.
Okay.
And then we changed to Python. So right now, I was like, okay, let's bring back C to my class. So what do you think? Should we stick to Kotlin or we just move on to C?
That's a good question. For those who couldn't hear, you started with C, you then switched to Kotlin so as to introduce object-oriented programming, then you switched to Python. And so the question is, should we maybe go back to C? Should we continue using Kotlin? I think it depends on the goals. Like Kotlin is particularly conducive to mobile apps nowadays. At least that's what Google, for instance, has been pushing in that space. And everything is in object really in that space, not unlike Java. So I think that's helpful if you want your students focusing on mobile in particular.
So yeah, because in the second year, they have to do Android programming.
Okay.
With Android Studio, so we thought that Kotlin is the best choice for them.
Yeah, I think this is where I'll be careful too, because I think in the world of programming languages, it's very much a religious debate as to like which language is best, which you should use. But I would say that if you introduce students first to C, a very common next language would be something like C++, which isn't technically a superset, but does add additional features on top of C. So for instance, you could spend maybe less time, maybe in this first class, introducing students to C, and then maybe in the last week, the last 2 weeks, the last 4 weeks, whatever seems appropriate curricularly, you could say that, well, structs in C only get us so far because there's no functions or methods built into them. So it turns out you can use this other language, which is almost just like C, but has classes, and you can make these objects. So you can start to bridge one or the other without completely changing syntax from one to the other. Or instead, if you liked your experience with Python, and maybe you still start with C, you can focus more on the object-oriented aspects of Python. And so, for instance, some of you might know, we actually have a class from CS50 called CS50P, CS50's Introduction to Programming in Python, and we spend like an entire module on the object-oriented aspects of OOP in that class. We don't touch it in CS50. So I think I would decide based on what you want where you want your students writing the code. Like if it is a mobile app, then maybe just focusing really on Kotlin makes sense.
So yeah, it's really focusing on mobile apps because I'm a vocational high school.
Okay.
So there are two departments, web development and Android development. So I'm teaching the Android development
Gotcha.
department. So that's why we use Kotlin. But now, right now, I'm kind of thinking that we should bring back C to the class.
I think, I mean, there's no one right answer, and I would encourage you as a group to, like during today's breaks, tomorrow's lunch, and like have that chat and solicit more opinions than just mine. But those are the kinds of thoughts that I would bring to the conversation. Yeah.
What is the reason behind Harvard video clip that you put on week 8?
Well, which aspect?
Harvard video.
Oh, the Harvard defense video. Okay, so you might recall in week 8 we showed the prank that Yale did on Harvard by having us hold up an offensive sign to all of the guests. So the motivation for it really was one, safetyschool.org, recall, was one of the domains that we played with, and I ran the command that showed us that safetyschool.org actually issues an HTTP redirect to yale.edu. And that's kind of funny, I think, but the catch is because we in CS50 back home also have Yale students at Yale University, not quite fair if we only pick on one. So I looked up a similar prank, and that one was maybe the best prank put on Harvard before, so we introduced that as well. That is certainly something you can omit, especially if your students don't care about Harvard or Yale, but the motivation was to make it an even playing field and picking on both. Yeah?
Yeah. Okay. One thing that amazed me about problem set in CS50 is the problem set provide fact that provide the story behind the problem that we should solve.
Okay.
I solved all the problem set, more comfortable or less comfortable, and thank God I got a good point of it. And I think I imagine that, just as for example, there are a learn algorithm, there are Feynman, there are runoff, there are plurality, something that make me amazed that how CS50 teams make a good problem set. And it's really left us as students to journey the problems. So can we later as a teacher take the problem set to our class?
Oh, yes, of course. Like, you can and should use.
Can we adopt or take the problem set, that very, very good, great problem set, to teach?
Thank you, and yes. Like, the answer to all questions like that will be yes. Like, the material is yours and what we'll discuss actually tomorrow in more detail is just how many problems are available, some of which we use for CS50 for teachers. There are yet other labs, as we call them, or practice problems, and you're free certainly to use some of those, all of those, none of those, and really adapt them to your own students. And in fact, Margaret tomorrow will talk about her own experience with her students, changing the schedule of the class, picking and choosing some of the problems more so than others, so more of that to come. And in fact, that's a perfect segue to what I thought I proposed is just some of the motivation behind some of those problem sets that you kindly note. So the very first you might remember is really one of my favorite games from my own childhood, even though I'm showing my age and perhaps now yours, in the fact that this is a very two-dimensional game versus what kids have nowadays, but Mario is with us in many forms. But this is an example of a problem where you have to make that half pyramid using like hashtags and ASCII art, if you will. And this is an example of a problem that could very easily be very boring. Like if you just ask students to print out a pyramid with these hashes that looks like this. Like, okay, but there's something more, I think, and something special about just giving them something to latch onto. That it's not as simple and boring as a black and white pyramid made out of hashtags, but it's like the beginnings of this game that they might know or already love or something familiar to them. And so almost always when Carter and I write the course's problem sets, we try to find that hook. Like, it's not enough to come up with the code. It's like, what is the angle? What is the image we're going to put at the very top of the problem set? What's the silly YouTube video that's just there for fun to click on to motivate you with some music or some TV or some movie clip or the like? Just something to make it very real and fun, even though it's kind of it's like from Mary Poppins, a spoonful of sugar makes the medicine go down. Actually incorporating just a little bit of fun, for a problem set that is still just for loops, like just code that does this, which in and of itself might not be nearly as engaging. So Mario is sort of representative of exactly that mindset. We also, and not all of you might have done this, there's the more comfortable version of this problem, where we take the same idea, and it's still going to involve some for loops and maybe some conditionals, but we make it a little harder. But it's sort of the type of problem where it's just kind of turning the knob a little bit. It's not making it crazy difficult in that week 1 of the class, but it's kind of difficult for many students to figure out, okay, it's very easy to do this, probably pretty easy to do this, starts to get a little annoying to do this, like in the middle. You have to think a little harder. And that's exactly the point. And so this is why we have more comfortable versions of some of our problems, is so that students who are very uncomfortable, have no prior programming experience, we want to give them a very low floor. So it doesn't take much to sort of get into the class. But for students who maybe have been programming for a while, or think they've been programming for a while, and are just more confident, justly or not, they have sort of a higher ceiling. So they don't walk into the same room and like have no room to grow. The ceiling is higher for them. And that's what we mean by these more comfortable problems. So a low floor for less comfortable, but a high ceiling for those more comfortable. And so Mario captures exactly that idea at the start of the class. Anyone recall? Very recently? We're not done yet.
This was...
It does say this was CS50, but this is an example in week 2 of the class where, recall, we introduced arrays and the beginnings of memory and data structures. And it's very easy to make arrays and conditionals and loops boring. And I honestly dare say from my own experience, like textbooks are very good, many textbooks are very good at making things boring. But if you contextualize that same problem and find that hook, all right, well, all we want students really to practice this week is strings, but treating them as arrays. Like, how could we actually make those strings interesting? So it occurred to us some years ago that, well, why don't we turn it into an example of cryptography and encryption and have a narrative around it and sort of bring the excitement to students, even though at the end of the day, they're just writing for loops and conditionals, but hopefully they're getting better at those building blocks at the same time. Now, we transitioned in week 4 to imagery, and you can't escape the popularity of Instagram and TikTok and similar platforms around the world nowadays that have filters that change the colors or do fun things with labels and the like. And so we use this as an opportunity, of course, to introduce low-level file I/O, input and output, reading a file, changing it, and the like. We deliberately choose the simplest file format we can for images, like a BMP file, even though no one really uses them much nowadays. But a BMP file is way simpler than a JPEG or even a PNG. So we use bitmap because it has a very well-defined structure that we introduce students to. And of course, if I advance here, now it's in black and white. Now we've detected all of the edges. And even though this too is a bunch of loops, but it's also a bunch of functions, because this is one of the first problems where we now give students distribution code. And so thematic in the class too is this notion of scaffolding. Much like you're doing repairs on a building, you start to build up those metal platforms or wooden platforms so that the humans can go up and up and up and work on the outside of the building. Scaffolding for us really means at the beginning of the class, we really just give students an empty file because we really want them to go from nothing to something. But if they have to start from scratch every week, no pun intended, like there's only so far they can go in just 7 days time or maybe 14 days time. So eventually we do introduce them to like library code, like the CS50 library, and thereafter distribution code, like code that we write and comment that they should read and understand, but then we have them start filling in blanks, sort of helping them realize how they can start to structure bigger, more sophisticated programs without spending a month implementing that program. If we had a month, I don't think that would be a bad approach, but if time is limited, we pick and choose exactly where we want our focus to be. So with this image problem set, do we focus on exactly that, the manipulation of files, but still using those same primitives? This demarcates the start of what kind of file? Let's say again. Not that. Not RGB.
Hexa.
It's hexadecimal.
Hexa.
I'm not sure I'm hearing the file form.